Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic Huffman coding. Let's get started. Huffman coding. So Huffman coding is a lossless data compression algorithm. This idea, the Huffman idea, is to assign variable length codes to input characters, and the length of the assigned codes are based on the frequencies of the corresponding characters. The variable length codes assigned to input characters are called the prefix codes. Means the codes are assigned in such a way that the code assigned to one character is not the prefix of code assigned to any other character. This is how Huffman coding makes sure that there is no ambiguity when decoding the generated bystream. Let us understand prefix codes with an example. Let there be 4 characters, namely A, B, C and D, and their corresponding variable length be 00, 01, 10 and 11. This coding leads to ambiguity because code assigned to C is the prefix of codes assigned to A and B. If the compressed bitstream is 0001, the decompressed output may be CCCD or CCCB or ACDB or AB and so on. So here are the major applications of the Huffman coding. So there are mainly 2 parts in Huffman coding. The most used is to build a Huffman tree from the input characters and then traverse the Huffman tree and assign codes to characters. So let's see with an example. Before that, let's see how the algorithm works. So let us take a simple example. So the message that we are going to send it to the receiver be BCC ABB DAECC BB AEDDC. Here we are going to use only the 5 characters of length 20. So in any electronic component, the alphabet is sent through ASCII code. The ASCII code letter capital A is 65 and therefore we need 8 bits binary to convert 65. So for one letter we need 8 bits. So for 20 letters we need maximum of 8 into 20, which is 160 bits. So let's see the ASCII code for value A. It is 65. So that would be represented as 0100000001. Same way for B, it is 01000010 and so on. So this is how it works for the ASCII code. Now let's see the simulation part. So first of all, we have to count to decide a Huffman tree, first of all we have to count the frequency of characters used. So we have to see the frequency of characters used. So first of all we will take the count. So for letter A it is 3, B it is 5, C 6, D 4 and E 2. So first write the frequency in the leaf of a tree, and that is the leaf node of a tree. Then between the root, then we have to form the Huffman tree. So then between the root node 5 and counts, take the maximum and then add them up. Here 5 and 4 are minimum, so we add them and make 9 as root node. So continue this process. So finally we will be getting a tree as given in the slide. So a tree would be looking like from left to right, the minimum value is assigned to the left end of the tree and the higher value will be assigned to the right of the tree. And please remember, the leaf node will always have the letters. So let's see. After preparing the Huffman code, we have to assign the code values to the message. So for that, what we have to do is mark the left hand edges. So we have to mark the left hand edge as 0 and right hand edge as 1 and then traverse from root node to any other letter. Suppose we want to go from root node, so the distance will be 001, for B 10 and so on. So this is called the variable length method. For A, we need 3 bits, B 2 bits, C 2 bits, D 2 bits, E 3 bits. For A, the count is equal to 3, so totally it will be 9 bits, and so on. So for B, it is only 2 digits, so the frequency of B would be 5, so 5 into 2, 10. So that is how it works. So for example, here A, it is 001 will be the code, and the frequency of A we have found earlier itself, it was 3. So 3 into 3, 9. For B, 5 into 10, 2, 10. And for C, it is 6 into 2, 12. D, it is 4 2s are 8. And E, it will be 6. So totally 5 bits. As we first see, we need 160 bits. So in the first itself, while seeing the problem, we saw the total number of bits needed to send the message, which is of length 20, is 160 bits. So here it will be reduced to 45 bits. Now we have compressed the cost and size. So what would be the time complexity of the Huffman algorithm? So the time complexity of the algorithm will be n log n, where n is the number of unique characters. So let us see the pseudocode of Huffman. So Huffman algorithm. So first we will assign n is equal to the mod of c, q is equal to c. Then we have to increment I to 1 to n minus 1, that is we have to allocate new node. So left of z equal to extract minimum of q, and z of right will be you have to extract minimum of q. So insert q comma z, so finally you will get the extract minimum result, that it represents the root. So this is the pseudocode of the Huffman algorithm. Let us see the applications. So the applications of the Huffman algorithm would be, it is a generic file comparison, that is the files such as ZZip, BZip, 7Z, archives like 7Z, file systems, NTFS, FS plus ZFS, these all will be using generic file compression. Then it can be used also in multimedia like zip image or zpeg image, sound mp3, video mpeg, HDTV, communications like ITU, TT4, V224, and databases that can use Huffman coding could be Google and Facebook. Now finally we will see what are the disadvantages and advantages of Huffman coding. So the advantages of the Huffman coding would be, the Huffman coding has the minimal average length. It is easy to implement and it is also very fast. The disadvantage of the Huffman coding will be, it requires 2 passes over the 2 input, one to compute the frequency and one for coding. The sense coding is very slow. It also requires storing the Huffman codes in the encoded file, thus reducing the compression benefit obtained by encoding. So that is all about Huffman coding. Thank you.